Alright, let's look at rational exponents. So here we have a to the 1 over n equals the nth root of a. So we want to be able to go from exponential to radical form and radical form to exponential form. So you can see here in the exponent, this denominator n here is the index of the radical. So let's use this to convert from exponential to radical form and radical to exponential form. So here we have 3 to the 1/2. So you can see here the 3 is our a and the 2 is our n. So this, we have the 3 under the radical, and our index n is our index, that's 2. But we don't put a 2, this is the square root, and it's just understood to be a 2. So this is our answer. Now let's look at y to the 1/6. Okay, a is y and n is 6. So this is equal to the 6th root, because n is 6, and then y, because a is y. Now let's take a look at this one, 13 to the 1/4. So this would be the 4th root of 13. Now let's go from radical form to exponential form. So you can see here n is 3. Okay, n is 3, and a is 29. So this would be 29 raised to the 1/3. And then this one, the 4th root of xy, well, what's underneath the radical here, this xy, is our a, and 4 is our n. So this would be x times y, and that's all raised to the 1/4 power. Okay. Now, what would we do if this exponent here is not a 1? Okay, well, we have this, a to the m over n equals the nth root of a, all of that raised to the m power, or the nth root of a to the m. Notice in one formula the m is outside. See, the numerator of the exponent is outside the parentheses, and here the m is underneath the radical. You can use either form, and you'll see in a minute the difference when we start evaluating these things and not just converting them from one form to the other. So here we're going to go ahead and go from this form, the exponential form, to this form over here. So here the m goes underneath the radical, and the n here is our index in the radical. Alright, so this is going to be 3 to the m, and m is in the numerator, so that's 2. And then n is our index, that's in the denominator, so that's a 3. So it's the cube root of 3 squared. Now let's go from radical form to exponential form. So here's m, which is 2, a is x, and n, our index on our radical, is 3. So this would be x raised to the 2/3. So that's converting from one form to the other. Now let's look at evaluating them. So let's evaluate 25 to the 1/2. So we're going to use this form here. See, 1 over n. I have in my problem 1 over 2. So if we convert this, we get the square root of 25, which is 5. Now let's look at this one, the cube root of, well, negative 27 raised to the 1/3. So this is the cube root of negative 27, and then the cube root of negative 27 is negative 3. And what about this one, negative 16 to the 1/2? So this is going to be the square root of negative 16. Now, we can't take the square root of a negative number. This is not a real number. Now, some of you may know how to evaluate this and know that this is 4i. But we're not going to get into this in this video. We'll talk about this in another video, a video on complex numbers. But for right now, we're just going to say it's not a real number. Now what about this one, negative 16 to the 1/2? Now notice the difference in problems 3 and 4. Notice here the negative 16 is in parentheses, and here it's not. Well, in number 4, this 1/2 exponent is with the 16. It's not with the negative sign like it was in number 3. So here we just have, we're going to do 16 to the 1/2, and 16 to the 1/2 is the square root of 16, and that has a negative sign out in front of it. So the negative sign goes outside of the radical. And then we can evaluate this, because the square root of 16 is 4 with a negative out in front of the radical, so that would be negative 4. Now let's look at these. Here we're going to use this property. Okay. Now when I evaluate 27 to the 2/3, I'm going to go from this form to this form. I'm going to put the m outside the parentheses, and I'll show you why in a minute. But let's just go ahead and convert it to this form. Let's put this numerator of the exponent, let's put it outside the parentheses here instead of how we did here. So here we have 27 to the 2/3. So that's going to equal the cube root of 27. See, the denominator of the exponent, that's the index of the radical, and then the 2, the numerator of the exponent, we're going to put that outside the parentheses over here. So now we have the cube root of 27 is 3, and that's squared. So our answer is 9. Now, let's suppose that instead of going from here to here, we went to this form. We put the numerator of the exponent underneath the radical. Let's just say we did that on this first problem here. Well, that would give me the cube root of 27 squared. So you can see the difference. Now I have to square the 27, and if I do that, I get the cube root of 729. Now I have to figure out what the cube root of 729 is. Well, the cube root of 729, it's 9. So you can see you're going to come up with the same answer, but this method here is much more difficult than this method. So whenever you're evaluating, I would use this form here. Okay, I would put the exponent outside the parentheses. It makes it a lot easier. Now let's look at number 2. Okay, I have a negative exponent, so the first thing I want to do, I want to make the exponent positive. So this is over 1, and I have a video on simplifying radicals, simplifying exponents, that shows you how to make the exponents positive. You need to watch that. So here, to make this positive, we're just going to move it from the numerator to denominator. So this is equal to 1 over 8 to the positive 4/3. So now I need to convert this denominator to radical form. So this is going to be 1 over the cube root of 8 raised to the 4th. So this is 1 over, and then the cube root of 8 is 2, and then that's raised to the 4th power. So I get 1 over 16. And there's my answer. Alright, let's look at one more. I have negative 8 raised to the negative 5/3. So I need to make the exponent positive. That's over 1, so I'm going to move it down to the denominator. So this is equal to 1 over negative 8 to the positive 5/3. Now notice when I move this down, it only changes the sign of the exponent. It does not change the sign in front of the 8. It only changes the sign of the exponent. So now I need to convert the denominator here to radical form. So this is 1 over the cube root of negative 8 to the 5th. So this is equal to 1 over, and then the cube root of negative 8 is negative 2, and that's raised to the 5th power. So this is equal to 1 over negative 32. And there's my answer. And that's all of this video. You can watch the second video on rational exponents if you need to.